Let's do one more example of finding the moment of inertia. Here we have a non-uniform disk about the central axis. In an earlier video, we derived the moment of inertia for a uniform disk to be 1/2 mr squared. But this is a non-uniform disk, which means its surface density changes as we get further from the axis, according to this equation here, some constant multiplied by how far away we are. The mass density right at the center would essentially be 0, because little r would be 0 there, and it would be maximized here on the outer edge. We want to find this moment of inertia. Let's use the definition and see where it leads us. Clearly, we're going to need to integrate from little r equals 0 to little r equals big R. Now, what's dm? dm is the differential, and we see once again that the differential and the limits of integration are not speaking the same language. So we need to somehow change this dm into a dr of some kind. Now, to do that, we need to look at the picture and figure out what dm is. Well, dm is this little ring here. It's supposed to be a perfect ring, but it's not very good. That's a distance r away. It has a thickness dr. That's dm right there. This surface mass density is gamma times r, and we said in an earlier video when we had a case like this, mentally what we do is we take this thin ring out and we stretch it out so that it has a height dr and its length is equal to the circumference of that, which is 2 pi times little r, and then that bit has a mass surface density of sigma. Now that sigma is specific to that value of r, and because of the equation, it's equal to gamma times r, and then this whole thing is dm right there. So what we can do is we can say, in general, sigma is mass over area. So for our case here, we're going to say sigma is mass over, now what's the area of this thing? Well, this is just a really skinny rectangle, isn't it? 2 pi r dr. So what's dm? Can I fit it on here before moving the paper? I think I can. dm is going to be 2 pi gamma r squared dr. For this specific case, according to how sigma varies, that's what dm is, and that needs to be substituted in over here. So let's do that. We're going to integrate from r equals 0 to r equals big R, little r squared, 2 pi gamma, another r squared dr. What does that yield? We've got some constants. 2 is a constant, pi is a constant, gamma is a constant. Then we're left with r to the 4th. So when we power that up, and then with our integration limits from 0 to r, I think we're going to be left with this answer. 2/5 pi alpha big R to the 5th.